Hi everyone, in this video we are going to go over three very simple, or in other words, basic stoichiometry problems. Now, this video is going to be followed up with another video that has more advanced stoichiometry problems, and that video is going to be followed up with another video that has limiting reagent problems. So this is broken up into three key sections. So I'd highly recommend you start here and then move throughout the other two videos. So let's start off with something simple. How many hydrogen atoms are in 15 grams of ethane, C2H6? Go. All right, did you get an answer? Hopefully you did. The only thing you could possibly start with is 15 grams of ethane, right? That's it. That's the only number we've given you, so you have to start with that. So 15 grams of ethane, C2H6, okay? We need to break this apart and go from grams all the way to atoms. So the only way you can do that is by going from grams to moles. So we're going to use the molar mass here first. So the molar mass of ethane is about 30 grams per every 1 mole. And now we know for every 1 mole, man, that line's not very straight, is it? So for every 1 mole of ethane, we have 6.02 times 10 to the 23rd molecules of ethane, C2H6, okay? But we need one more step because this is molecules, and we actually have to figure out how many hydrogen atoms are within that molecule. And so what we do is we go right here to the molecular formula. So we see that it's C2H6, right? So we're talking about hydrogen. There are 6 hydrogen atoms in every 1 molecule. So we just need to write that out here. For every 1 molecule of C2H6, we have 6 hydrogen atoms. That's it. That's all you have to do. Because if you go through here, you can see that your grams cancel out, your moles cancel out, your molecules cancel out, and you're left in hydrogen atoms. So if you put this in your calculator properly, you have 15 times 6.02 times 10 to the 23rd times 6 divided by 30, and you end up with an answer something like 1.806 times 10 to the 24th hydrogen atoms. Pretty straightforward. Now let's try something from the reverse direction. So if you know that you have 7.4 times 10 to the 24th nitrogen atoms, what is the mass of all of the N2 molecules that you have? Go. All right, did you get an answer? It is definitely a little bit more difficult to go from atoms to mass. I'm not really sure why that is, but I can say definitely from the history of my students, they struggle with this more than the first problem. But really, it's the same thing. If you can do the first one, you can do this one. So let's start off with what we know. We have 7.4 times 10 to the 24th N atoms, so single, okay, monatomic atoms. Now, we know if we were to look at a molecule of nitrogen, there are 1, 2 N atoms. So we are 2 nitrogen atoms in every 1 N2 molecule. Okay, I'm abbreviating molecule like that just for the sake of space. And so now we know, okay, this number never changes, that there are always 6.02 times 10 to the 23rd molecules in every 1 mole, okay, of nitrogen. So there's 6.02 times 10 to the 23rd N2 molecules in every 1 mole of nitrogen, but we're trying to go to mass, so we need to go one more step and use that molar mass. So we get this directly off the periodic table. For every 1 mole of N2, don't forget that it's 2, you have 28 grams, so it's approximately their molar mass, okay? So now, again, if you put this in your calculator properly, so 7.4 times 10 to the 24th times 28 divided by 2 divided by 6.02 times 10 to the 23rd, you end up with a proper number of 172.1 grams of N2, okay, diatomic nitrogen. Now remember, if you're not getting this answer, it's probably because you're entering this in your calculator incorrectly. If you're doing it properly, it should look something like this: 7.4 E and then 24. Same thing here. It would be 6.02 E to the 23rd. Okay, that's the number you should be using. If you're typing in times 10 little caret to the 23rd, you are going to make a mistake, especially on those small, awful calculators that we have to use. So please, please, please try to take advantage of that EE button. All right, let's do one more before we move on to the next video and do more hard stoichiometry or more challenging stoichiometry. So let's just do this one here. How many atoms, so atoms, that's the question, are in 1.4 grams of ethanol? And I've given you the structural formula for you, okay? Go ahead and try that one. Did you get it? Hopefully you did, and the only way you could have done this properly is if you start with the number 1.4. That's the only number there. That's the only number you could possibly use. So you know you have 1.4 grams of ethanol. Okay, so I'm going to abbreviate this to be C2H6. 0.60, okay, just to make it a little bit shorter so I can have a little bit of space here. So we know by using the periodic table and maybe even a calculator that you can determine the molar mass of our ethanol, and so that's approximately 46 grams for every 1 mole. Okay, and now we know that for every 1 mole of ethanol, there's 6.02 times 10 to the 23rd molecules of ethanol. But this question was tricksy, and they asked us to go to actually atoms, not just molecules. So we need to say that for every 1 molecule of ethanol, there's blank atoms. Now, this is usually the part where people get stuck. How many atoms? We're talking about total atoms, so you literally just have to count. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9 atoms total. I think it's sometimes easier to count from here because you have 2 plus 6, that gives you 6, 7, 8, plus 1 gives you 9, so you have 9 atoms total. If you put this in your calculator properly, so 1.4 times 6.02 times 10 to the 23rd times 9 divided by 46, you would get an answer something like 1.64 times 10 to the 23rd atoms total, okay? So if you have 1.4 grams of ethanol, there's 1.64 times 10 to the 23rd atoms there possible, okay? All right, so this is our basic stoichiometry video. If you felt good about this, please move right on to the next stoichiometry video. If you did not feel good, you need to stop and do more problems like this before you even have a shot at doing well at the next video, okay? Study, 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 and drink lots of water.